Hello guys, welcome to today's class. Last Our last class we considered um, elasticity, where I told you guys about the elastic materials and the rest. We also defined elasticity as well. Now today we are going to consider, it's as if I also stated Hooke's law, where I told you that Hooke's law states that the force of the force applied to an elastic material varies directly as the extension. Are you getting me? Varies directly as the extension. Provided the elastic limit is not exceeded. Normally, F varies as E. That is normally. Then F, if we remove sign of proportionality, we introduce a constant. And what is that constant? K, equal to Ke. This E we have is extension, while this F is the force. Then K, where K is called elastic constant. Elastic constant. We can also call it stiffness. We can also call it force constant. You can see the names. Are you getting me? Now, this is Hooke's law. Is that clear? This is Hooke's law. And normally, if, let's say, a wire is stretched from a particular value to a particular value, how do we solve such problem? And there is something you must take note of. We have some materials that can obey Hooke's law. And what are those materials? We have your spiral spring. Spiral springs can obey Hooke's law. Is that clear? Anything that can extend, are you getting me, can obey Hooke's law. Are you following me? Don't forget to subscribe. And don't forget to watch this video to the end so that you can enjoy more benefits about elasticity. Do you understand that? Now, when we talk of that, let's say we have F1 as 20 Newton, and this force is applied to an elastic material. And let's assume the elastic material has a length of let's say a length of 10.01 centimeter. Let me use meter. Is that clear? And this is the length. Now it is extending now to 10 point, please let me use this as 10.00, 10.02 meter. So this is the initial length, that's the original length of the material. But this length of the material is extending to 10.02 meter if a force of 20 Newton is applied. Are you getting me? Now, in this case, if this is your F1 that you applied to this 10.00 meter to extend it to this, that means extension is equal to L2 minus L1, which is 10.02 0.02 minus 10.00. That will give us 0.02 meter. Are you with me? Now, at the end of the day, we cannot say we are looking, according to the question, we are looking for, let's say, F, if a force, that's another force now, F2, is applied. Let's say this F2, if a force of 60 Newton, let me use 80 Newton is applied. Do you understand that? So this same 10.00 meter, you know, when you apply this, it extended to this. What about if you apply this? What would be the extension? Not the new length now. What would be the extension? So in this case, we have got this one is like E1. Now we are looking for the extension. That's E2. I will call it E2. Question mark. We'll now say F normally is equal to KE. And F1, do you understand that? If we make K the subject of the formula, we can say K equal to F over E. It means F1 over E1 equal to F2 over E2. Our F1 is 20, E1 is 0.02, F2 is 80, we did not know E2. That's what we are looking for. Now, if you cross multiply, this will multiply this, that's 80, please look up, 20 E2 equal to 80 times 0.02. So, 80 times 0.02. Here we can now say E2, we divide both sides by 20, is equal to 80 times 0.02 divided by 20. This here 1, this here 4. So 4 times 0.02, that would be E2 equal to 0.04 meter. So this is the extension. When a force of 80 Newton is applied to that same material that was initially having 10.00 meter. Exactly. Now, supposing this was given in centimeter, you need to convert from, after getting the extension, you convert this centimeter, supposing it is centimeter, you convert the centimeter to meter. And how do we do that? Centi is 1 over 100. That means you divide this one by 100. Centimeter is 1 over 100 meter. So if you divide this by 100, you will now get the answer converted to meter. That is if this was to be in centimeter. But now we are using it according to meter. So it's going to be as it is. Exactly. Now, that is Hooke's law. The next thing we will consider will be the energy. But before we do that, it will be in our next class. The energy. I will just give the formula. The energy in an elastic material. Energy in an elastic material. Normally, the energy, I'm going to use W, that's work done. Energy is equal to half Fe. We can call that 1. Force times the extension. Half of force times extension. Then, we can also say, normally F is equal to Ke. It means if F is Ke, if we bring this Ke, put it here, that will be W equal to half Ke times E. which will give us half Ke squared. That is equation 2. We can also use this. That is if force is not given, but constant is given. And again, we can say if we now make E the surface of the formula here, it will be E equal to, but E equal to F over K. Now we are going to put this one again in this place. That will be W equal to half F times F over K. This will now be half F squared all over K. That is formula 3. So these are the 3 formulas we have when you are solving problems in energy stored in an elastic material. Do you understand that? Don't forget to subscribe and watch the video to the end. Ask any question, use the comment section to ask any question. Thank you, and thank you very much. Thanks for watching.